AI model, the video 9 DNN Flow.mp4. Based on the context of your animated Sankey diagram for AI DNN with 11 hidden layers and 2 output layers, here is a detailed explanation of the video from both management and mathematical perspectives. Management perspective. The video illustrates the AI engine's decision-making pipeline, layer by layer, in a clean and animated fashion. This helps leadership and project stakeholders understand how AI systems think and where human-defined processes align with data-driven intelligence. Chart increasing breakdown for management. Stage what happens management value. 1. Input normalization. Raw data is standardized, ensures consistent, unbiased inputs from multiple systems, ERP, CRM, etc. 2 to 4 feature layers. Filters, reduces noise, and enhances signal, improves decision quality by focusing on relevant data. 5-dimensional compression. PCA condenses info, saves computing cost while retaining core business insights. 6 to 8 reasoning layers, identifies patterns and logical relations, mimics domain expertise, example finance risk or healthcare diagnosis. 9 to 11 risk and confidence, estimates risks and confidence levels, quantifies uncertainties and provides business-ready recommendations. 12 to 13 output layers, provides classification or risk scoring, supports dashboards, predictions, and automated workflows. Key message to management. This AI model is a structured decision engine, cleaning, analyzing, reasoning, and delivering predictions, making your data work intelligently for every department. Mathematical perspective. The video animates how a deep neural network, DNN, operates using layer-wise transformations of data, guided by linear algebra, probability, and activation functions. Brain breakdown for mathematics. Layer formula. Math concept. Input normalization. Z equals x mu sigma. Z equals \frac x, \mu sigma. Z equals sigma x mu. Statistics, standardization. Feature filtering. Z equals sigma yxc plus b, a equals max, 0 z, z equals \sum w underscore I x underscore I plus b \a equals \max, 0, z, z equals sigma yxc plus b, a equals max, 0 z. Linear algebra plus ReLU, piecewise function. Feature enrichment. A equals leaky ReLU, z, a equals \text leaky ReLU, z, a equals leaky ReLU, z, nonlinear mapping. Dimensional compression. A equals PCA, z, a equals PCA, z, a equals PCA, z, eigenvalue decomposition. Pattern recognition. A equals 10, z, a equals \10, z, a equals 10, z, hyperbolic functions. Risk estimation. A equals sigma, z, equals 11 plus EZ. A equals \sigma, z, equals \frac 1 plus E caret Z. A equals sigma, z, equals 1 plus EZ1. Probability, sigmoid. Classification, multiclass, y caret I equals EZ I sigma SJ hat y underscore I equals \frac E caret Z underscore I \sum E caret Z underscore J y caret I equals sigma SJ. Multivariate calculus, softmax. Key message for mathematicians/data scientists. Each neuron computes a weighted sum and applies a nonlinear function, allowing the network to learn non-obvious patterns across large data sets. The progression from linear filters to probabilistic outputs is governed by applied math at every layer. Summary. Video title, Animated DNN Flow, AI model by Pradeep K. Suri. For management, shows how AI systems transform messy inputs into clear outputs through logic and learning. For technical teams, each animation step corresponds to real math behind DNNs. For strategy leaders, confirms AI can align with business KPIs, risk metrics, and compliance logic. Author keynote, by Pradeep K. Suri. As the architect behind this AI model, my vision is to bridge the gap between complex mathematics and real-world decision-making. Every layer in this DNN reflects not just computation, but business logic, risk awareness, and strategic insight. Whether you're a leader, educator, engineer, or learner, this model empowers you to see AI not as a black box, but as a transparent partner in transformation. Pradeep K. Suri.